Yeah, so hi everyone. Thanks so much for joining just right before the lunch break. So I'm Alina from Pioneers, and today I would like to share some lessons learned from using LiteLLM in real-world projects. So throughout my talk, I would like to show you how the project works and some things I learned while using it in a productive setting. So let's imagine there's a private university who would like to implement their own privacy-preserving chatbot and make it accessible for both students and employees. And they ask us, so all of us, to actually implement the system for them. So yeah, you know, in this fast-paced world, no one really knows like which kind of models will arise in the future and which ones we would like to use. So the first requirement is that models should be, like models in the sense of large language models, should be easily updatable. And additionally, it may make sense that we are also able to self-host our own models if we decide so in the future. So for that, LiteLLM is actually one possible choice as it fulfills all these requirements. For that, LiteLLM generally provides two options, a Python library and a Proxy server. So let me quickly go over the Python library. It actually provides a unified API for different models, and you can do that as you see here in the code snippet at the right. You just call the LiteLLM library, for example, with an async completion method, hand over your model, messages, some other settings, and of course, like the information to your model, like where your model is hosted, an API key, and a URL. And you have like some further features and integrations I don't want to talk about now. So the second option is a proxy, which is basically a server, an OpenAI compatible server, which sits between your application and different model providers. And the cool thing about it can also issue API keys for you. And so, for example, in our context, if you may imagine, there are courses in computer science or other subjects who may want to do projects experimenting with generative AI. And then we could easily give them an API key to our server, and they can use this in all kinds of applications or libraries, which allows for a custom OpenAI URL. So yeah, I think the proxy rather provides more flexibility for future requirements. So let's go with that one for the moment. Calling it is quite easy as well. You can either call the URL directly. So at the top, you see, I just hand over the URL where I host the server, give it some headers for authentication, and then hand over my data with the model, messages, further settings, and so on. And then just call the URL with all these data and headers and get a response back. The second option would be to use the OpenAI library directly, as it is OpenAI compatible. So I can use this OpenAI client, hand over my API key and the URL, and then I'm ready to go with all the OpenAI kind of features and methods. So, well, now you know how to use it, but we first have to set it up, of course. The setup is quite easy as well, as you can just get a Docker image, which you can host anywhere where you like, and you mount a configuration file to your Docker container as a volume. And an exemplary model, like configuration file may look like, you see at the right, we do have two models we would like to use, GPT 4.1 and the DALL-E 3 model. We hand over, again, like our API key and URL, where our model is hosted, and which is quite important, we need to match it to the LiteLLM specification of this model for example, if we host it on Azure, then we need to tell it, okay, it's this Azure GPT 4.1 version, so that actually other stuff internally will be mapped correctly. Additionally, I can hand over model information, which I can also later retrieve using a model information API. So yeah, there are further setup options. For example, a PostgreSQL database, which is needed for features like budgeting, I will talk about in a minute. And you can also set up a Redis cache, which is needed for features like load balancing. So let's imagine we completed all this proxy setup and also implemented our chat application, and now the chatbot actually goes live for all students and employees. But suddenly we realize, well, the costs for using all these models are much higher than we initially expected, because there are a lot of power users in this sphere. So, but that's no problem for us, as we already have LiteLLM in place. So we just need to deploy a PostgreSQL database and connect this database with LiteLLM. And then the cost to automatically get saved into the database. So how does that work roughly? LiteLLM internally has a huge JSON file where they gather all the information which are needed for one model, and which is important for us now is in this yellow box. They also have like the input cost per token and output cost per token, which they specify and update for all models. So then we can use, for example, now the OpenAI client library, send some messages there, and what is important is the last word of this code snippet, hand over a user ID as well. And so what now happens in the background is that costs for this user are automatically calculated, or for this call are automatically calculated during the request, and then in the background the costs are assigned to this user, which are specified in the request. So the nice thing about this whole process is that we do not need to deal with the pricing updates on our own, because like we may host a lot of different models in the future and do not want to keep up with all the pricing changes. However, we regularly need to update our proxy server, thus deploy a new Docker image version, otherwise we do not get the updates of the prices in as well. So how does this process look like? First, we can create a budget using a certain kind of input. Then add a team. In our use case, I would say we start easily with just having two teams. One is the student team and the other one is the employee team. And they do get, and there are then different team members assigned, so either students or teams. And we add a certain budget to each of these teams. So now, what I said earlier already, we just need to hand over some kind of user information in all of our requests. And in the background, LiteLLM automatically checks if the budget is already exceeded for this user or not. And if it is exceeded, it just results in a budget exceeded error. And lastly, we can then, of course, also retrieve like the budget and the current costs a user spent in one API, which is a bit weird. It's like a customer info API, and customer are like basically all the users you use in your application. So all that sounds quite good for us developers. We could handle some endpoints. But what about all the non-technical colleagues who would also like to handle stuff on their own, do this administration with the budgeting stuff and other things? So out of the box, deploying the proxy server, we already get an admin user interface delivered as well. This is a screenshot of one example of it. Here we can do most of the process I just described earlier to assign budgets, handle teams, and all that other stuff. But unfortunately, in this admin interface, we can't do everything yet, which we are able to do with the endpoints. And additionally, we need to keep in mind that there are some enterprise features where you need an enterprise license for. And here I think most useful would be the feature to connect existing single sign-on providers to LiteLLM. Just another short example of this admin user interface. Of course, it also provides options to monitor all this budgeting stuff, all the costs which arise. For example, in the upper right, you see the spend over different models, and on the down side, the spend by different provider, which we can use, of course, to derive further insights from. So we now have a working chat applications with some basic budget control so that we don't exceed our budgets, which are set anymore. But of course, more budgeting requirements do arise in the real world. So, well, the first request is, can we actually show users the costs for each chat or each message? Because as a university, we would also like to educate our users, like which kind of requests are expensive and which ones may be less expensive. So yeah, that's something actually which is not available out of the box, as LiteLLM does not allow us to send any custom metadata to this request interfaces. And so also these kind of things are not saved do not get saved to their database. But instead, we need to somehow handle this on our own. So a potential workaround would be using the cost information we get back in request headers and implement our own process around that. So yeah, a second request would be, well, there are so many courses which use kind of which use the API keys, for example, and they should be also allowed to use more of their budgets. For example, for a semester project, and here that's why they ask us if we can implement some temporary budget increases for just some sub-part of the users. So unfortunately, LiteLLM has something like that, exactly for API keys in their enterprise version, but not for individual users or teams, which we would need in this case. So again, that's something which is not available out of the box, but of course, we could implement our own process around that. So take out all this budgeting stuff from LiteLLM, handle that on our own, and then somehow wrap the LiteLLM calls into our own budget check. Or, of course, try to bring all these features into the project itself. So we do have a cost control in place, but we cannot avoid too many users trying to use our system at the same time. So let's imagine we have like different users accessing our chat application at the same time. And what we do in the background is we use LiteLLM to, for example, route our requests to a GPT-5 model. So if the capacity of the GPT-5 model is exceeded, we do get back some rate limit errors, which we can handle, of course, in our chat applications by using some kind of retry logic. But eventually, yeah, there are still too many requests at the same time, which we can't handle. So we decide we could deploy a second model somewhere else so that we have like maybe this capacity doubled. So that's also something where we can now leverage LiteLLM's routing strategies. So just in this configuration file I already showed earlier, we have the different models which we deploy, and we can also deploy the same model different times. And then you see here there is like a TPM and RPM with numbers. TPM means tokens per minute and RPM requests per minute. So these are actually the limits these two models can take. And well, what we do set are the router settings. So there are some kind of algorithms they use to direct our requests to each of these models. And then, well, as I said earlier, very in the beginning, for this kind of feature, we need to deploy a Redis cache and then provide all the Redis cache information in this configuration file as well. So finally, we could also use some kind of fallback model if all of that still exceeds the capacities at any moment. So that we then route our requests further to a fallback model. So using this exemplary use case I tried to introduce to you, I presented some of the pitfalls I encountered while using LiteLLM in production, but of course, not everything. Just ask me later if you want to hear more about that. So I now want to present some parts where I think you should be cautious if you consider using LiteLLM. So, well, what might be common sense is, of course, with every project, with every library, you do have some kind of abstraction layer. And that may be nice because you don't need to handle all the complexity on your own. But in this case, it may also mean that in some points you don't get all the provider specifics you may need in your certain project, as they did not implement this into LiteLLM yet. And additionally, well, there are always brand new models out there. If you want to use them through LiteLLM, you first have to wait until they integrated these models into the library. Well, I talked a lot about the budgeting stuff. That actually works quite good out of the box to provide this basic cost control thing. But in my experience, if you get super specific customer requirements on all this budgeting and cost handling stuff, LiteLLM may not fulfill all your requirements, and then you need to see how you handle all this stuff on your own. And lastly, I feel that LiteLLM, of course, is a fast-paced project in this generative AI area. And it's really cool to see that they always develop tons of new features. But I feel like at some points, also like already existing features were kind of buggy. And so when you wanted to use them in production, you needed to fix them first. Or also like all these fancy new features didn't 100% work the way you think they should work. So to wrap it up, when should you consider using LiteLLM? I think it's really great if you need multiple providers, multiple models, and have these kind of governance needs, like the cost control, for example. Additionally, they do offer tons of external integrations, which I didn't go into detail yet. For example, they have a lot of LLM observability tools, which you can also use in other cases like LangFuse, MLflow, OpenTelemetry. And the good thing here is that you can direct just with one call to LiteLLM, you also have all the information available in these other external integrations. Yeah, of course, you can consider just using the LiteLLM, the Python library, instead of the server if you do not need all these proxy features like API keys. For example, budgeting is also possible with the library. However, I personally felt that like some new features and bug fixes are first available in the proxy and just afterwards in the library. So yeah, the proxy felt sometimes a bit more stable. Yeah, as I said earlier already, be careful if you want to use provide very many provider-specific features. and do have a lot of custom requirements. And well, as it's a very fast-paced project, if you do not have the time or the capability to contribute to LiteLLM on your own to fix things, or maybe temporarily patch your own version, have your own Docker image, then it might be tricky. Yeah, that might be obvious. You don't need LiteLLM if you use one provider only or do not have any governance requirements. So finally, like most of the things I talked about, like especially this unified API, kind of API gateway for different models and budgeting is also implemented now in other projects like OpenRouter or TensorZero. So before considering LiteLLM, you might also want to have a look into these alternatives as well. Yeah, thank you.
Thank you very much for the presentation, and we actually have a few questions. So let's start with the one on top. Can you also use the LiteLLM Python API to send requests to a LiteLLM proxy in order to stay independent from OpenAI Python library?
I never tried that, but I think that should be possible. Yeah, why not?
Okay. Thank you very much. The next one is, I tried using the OpenAI library on LiteLLM with Gemma 3 and GPT OSS. Accessing LiteLLM via the API, they seem to require different input, even though both are compatible with the OpenAI API. Do you know how to use the API as model agnostic as possible?
That's a very good question. I know that we also had like problems with that at some point, but like with our model combination, it was somehow possible. I'm afraid I can't answer this question.
Okay, thank you very much. And the next one is LiteLLM able to automatically manage and store threads in Postgres as it does with budgeting, in case we decide to switch LLM provider?
So what is it, threads?
Store threads in Postgres. I don't fully understand the question. Is the person asking could explain more? Yeah, shed some light.
So instead of passing all the entire chat history, you may store a thread where everything gets appended, all of the messages. So then you can connect, let's say, from one agent to the other agent, and you just need to plug the thread instead of passing the entire chat.
To my knowledge, that's actually not possible yet in LiteLLM. I think like basically in the Postgres, you see a lot of tables related around this team stuff and all the spend logs and all the information they actually do have, but no other information. And it's also like I said, I actually want them to store metadata for me, for example, and then retrieve these things by these metadata, but that's also not possible.
Thank you very much. And the next one is, would you recommend to use LiteLLM for private projects to prevent burning money and to have some observability?
Yeah, I think like, for example, I know like a friend of mine used now LiteLLM together with OpenWebUI. I don't know if you know this project. This was, yeah, it's really nice to get started, to have a chat interface and then connected to this OpenAI compatible server. Yeah, I think it's quite nice also in a private project if you just want to try out different things. But honestly, I don't know if you need this observability in these cases, but you need to decide.
Okay, thank you. And the last one is if there are so many problems with LiteLLM, do you still recommend to use it, or do you have some other suggestions?
Yeah, that's a very good question. I'm always asking this question myself. So I think for the last year, we started using it last year, I think. And at this point, there was, to the best of my knowledge, no other big library out there who provided this API gateway thing and also the cost, the budgeting stuff, which we really needed. And from that part, it was the best decision there. But now I feel like, okay, you always read the documentation. There are so many nice features. Okay, cool. They already implemented it, but I got kind of frustrated trying these new features and then realizing, okay, they don't work as I expect them to be. So I don't have proper experience with other libraries to really recommend them. But I also heard LiteLLM actually does add some latency and more latency than other libraries do. Like in my use cases, this was not a problem. I don't know, you had 200 milliseconds more of a latency in the setup, but yeah, that of course depends on the use case.
Okay, thank you very much. That was all of the questions we had. Thank you again for the great talk.